Picture the Earth 265 million years ago. This was the Permian period, a world at its peak, yet teetering on the edge of disaster. It was an age of extremes, a turning point in Earth's history that closed the book on the Paleozoic era and set the stage for the rise of the dinosaurs millions of years later. The land was ruled by Pangaea, a supercontinent so vast it nearly touched both poles. Its interior was harsh, dry and unforgiving, a land of endless deserts and scrublands where summers baked the earth and winters cut like ice. Rain was rare, rivers came and went with the seasons, and drought could turn fertile ground into cracked wasteland overnight. Survival wasn't a guarantee, and it was a fight every single day. And yet, life thrived. The Permian was a golden age for synapsids, the group of animals that would eventually give rise to mammals, and ultimately, to us. They came in every shape and size imaginable. Nimble insect eaters scurrying in the undergrowth, massive barrel-bodied herbivores grazing on tough plants, and predators so terrifying they make even the fiercest Jurassic killers look tame. The Gorgonopsians were among the most lethal, sleek, saber-toothed hunters with jaws that could shear flesh and bone in a single bite. Enormous Parasaurs plodded across the plains, their bodies covered in thick bony armor as they fed on whatever vegetation they could find. And then there were the bizarre Anteosaurus, a bulky, horned omnivore that looked like a mashup between a hippo and a demon, a true oddity of its time. And of course, the most famous of them all, Dimetrodon, with its iconic sail-backed silhouette. It's become the unofficial mascot of the Permian. But Dimetrodon wasn't a dinosaur. It was one of us, a distant cousin on the mammal side of the family tree. Its serrated and crushing jaws made it an efficient, bone-snapping ambush predator, lurking just out of sight, waiting for the perfect moment to strike. But even Dimetrodon, the so-called king of the early Permian, was not the final word in terror. Fast forward a few million years into the Middle Permian, and the throne of apex predator belonged to an animal that almost no one talks about today, a creature so large, so powerful, that it towered over nearly every other hunter of its age. This was Anteosaurus. Its name means Antaeus lizard, after the giant of Greek mythology. And it's a fitting name, because this animal was a giant in every sense of the word. Anteosaurus was a dinocephalian synapsid, part of the same distant family tree that would eventually lead to mammals. It lived in what is now South Africa during the late Guadalupian or Middle Permian, around 265 to 260 million years ago. The fossils we have, mostly skulls and a handful of bones, tell us it was an absolute heavyweight of its time. Adults reached 5 to 6 meters long, that's up to 20 feet, and could weigh as much as 600 kilograms. That made Anteosaurus the largest land predator of the entire Permian period, the undisputed top hunter of its ecosystem. Its skull is where the story gets really interesting. Anteosaurus had a thick, reinforced head. The bones of the skull were pachyostosed, meaning they were extra dense and thickened, though not as much as in its plant-eating cousins, the Tapinocephalids. It even sported horn-like ridges above its eyes, which gave it a pretty intimidating look. Paleontologists have debated what these skull features were for. Some think Anteosaurus used its head like a battering ram, shoving rivals around in contests for dominance or mates. Others suggest that all that bone served a more practical purpose, strengthening the skull against the stress of biting into big, struggling prey. And big prey was exactly what it hunted. Anteosaurus's teeth and jaws were built to take down massive animals, creatures like titanosuchids, tapinocephalids, and parasaurs, some of the largest plant eaters of the Permian. Its body was made both for strength and speed. Studies of its inner ear suggest it had excellent balance, sharp vision, and was likely more agile than you might expect for such a large predator. It probably relied on quick bursts of speed to ambush its prey, and when it connected, its sheer power would have been devastating. Interestingly, Anteosaurus didn't start life with its thick skull. Juveniles had relatively slender, narrow skulls, and as they grew older, the bones gradually thickened, a process known as pachyostosis, until they developed that characteristic heavy, reinforced head seen in adults. Anteosaurus may not be as famous as later apex predators like T-Rex, but in its time it was every bit as fearsome. A skull-thickened, power-built predator ruling over a dangerous world on the brink of disaster. The name Anteosaurus has caused some confusion over the years. It's often translated as before lizard or primitive lizard from the Latin prefix ante, meaning before, but that's not actually its origin. When British paleontologist David Meredith Sears Watson first described Anteosaurus in 1921, he gave no explanation for the name. According to researcher Ben Kreisler, however, Anteosaurus does not come from Latin at all. It refers to Antaeus, the giant of Greek mythology who was said to be invincible as long as he touched the earth. Watson likely chose the name to evoke the image of a powerful, earthbound giant. Fittingly, the first known fossil, the type specimen, was an incomplete skull Watson had originally assigned to Titanosuchus, another predator named after the Titans. Once recognized as a distinct genus, the name Anteosaurus carried on that mythological theme, linking this apex predator to yet another legendary giant. The skull of Anteosaurus is nothing short of impressive. In the larger specimens, it measured between 80 and 90 centimeters long, nearly a full meter of solid bone and muscle attachment. The skull roof was heavily thickened, giving it a reinforced, almost helmet-like appearance. One of its most striking traits was a pair of horn-like bosses, as I mentioned before, bony protrusions above the eyes formed by the postfrontal bones. These projected outward to the sides, giving Anteosaurus a menacing, broad-headed look. Even the lower jaw came equipped with its own battle gear. It carried a thick, oval-shaped boss on the side, a swollen patch of bone that may have anchored massive jaw muscles, or maybe even acted as a battering point for head-to-head shoving matches. Some fossils even show evidence of an extra boss on the cheekbone, which suggests that some Anteosaurus individuals might have been even more decorated, maybe more intimidating than others. But this skull wasn't just about looking scary, it was a carefully engineered killing machine. Behind the eye socket, a forward-curving bone opened up extra space for jaw muscles, allowing for a bone-crushing bite. The snout tilted upward, then curved slightly downward at the tip, creating a subtle scoop shape in front of the massive canines, perfect for gripping large prey and tearing into flesh. Sitting on top of the skull was the pineal boss, a rounded bump of bone that may have been used for display or combat, perhaps even for headbutting. Interestingly, this feature wasn't connected to the jaw muscles like in some of its relatives, so it probably wasn't there to strengthen the bite. It was likely there to be seen. And Anteosaurus didn't stop there. Even the roof of its mouth was weaponized. The palate bones expanded into broad, palm-like plates and carried a pair of tooth-covered bosses. These were spaced apart, unlike in its close relatives, which means they might have helped pin down prey or keep a struggling victim from wriggling free. Taken together, the skull of Anteosaurus was more than just a head. It was a display of dominance, a fortress of bone, and a deadly weapon all rolled into one. The teeth of Anteosaurus are nothing short of impressive, a perfect match for a top predator of the Middle Permian. Its jaws were lined with long, interlocking incisors, massive canines, and a row of smaller but surprisingly sturdy postcanines. And just to make things even more efficient, it had tiny recurved teeth on the roof of its mouth, perched on bony ridges called palatal bosses. Usually, there were 5 incisors up top and 4 on the bottom, though the count could vary a bit from one side of the skull to the other. These incisors weren't just sitting there randomly, they locked together with precision, almost like the teeth of a zipper. In fact, the first pair of upper incisors were designed to fit neatly between the first pair on the lower jaw, giving Anteosaurus a tight, effective bite. The canines were the real showstoppers. The upper ones were huge and thick, though not quite as exaggerated in some of its Gorgonopsian cousins. Interestingly, the upper and lower canines didn't interlock. Instead, when the mouth closed, the lower canines tucked just inside the last upper incisor, a clever way to keep everything aligned. Behind the canines came 4 to 8 postcanines. These were smaller but built like little pegs with thick bases, perfect for holding onto prey. The last few were especially interesting. They were angled backward and outward, almost as if the back of the mouth was designed to trap anything trying to escape. Even the roof of the mouth had a job to do. Those palatal bosses I mentioned earlier were lined with tiny curved teeth, usually in a single row, but sometimes in 2. They acted like meat hooks, helping Anteosaurus keep its food in place while swallowing. Put it all together, and the dentition of Anteosaurus was an incredibly well-tuned system, part slicer, part gripper, part clamp, built to take down big prey and process it with brutal efficiency. Postcranial fossils of Anteosaurus are rare, but one remarkable discovery, a well-preserved left hand from a young individual, has given scientists key insights into its anatomy. The hand revealed that Anteosaurus had the same finger pattern we see in mammals today, 2, 3, 3, 3, 3. The first finger was quite small, while the outer fingers were the longest, with the 5th finger being the thickest and strongest. By comparing these remains to the more complete skeletons of its Russian relative, Titanophanius, researchers believe Anteosaurus had long limbs and likely walked with a semi-upright posture, unlike the fully sprawling stance of earlier reptiles. Its tail was also relatively long, probably helping it balance as it moved through its environment. The skulls of Anteosaurus are honestly one of the coolest things about this animal. No two are exactly the same. Some had big, thick postfrontal horns and a huge bump on the forehead called a frontal boss, while others had only one of those features, or barely had them at all. Even the toughest-looking skulls are different from each other. In some, the horns stand out the most, and in others, the boss is the main feature. Part of this probably has to do with age. Younger Anteosaurus was still growing into those features, but in adults, the differences might have been tied to sex. It's possible that males had bigger bosses and horns for showing off, or even for headbutting, kind of like how rams or deer use their horns today. Scientists think Anteosaurus might have used those thick skulls to settle arguments without killing each other. Biting with those giant canines would have been risky. One good bite could be fatal, so headbutting was probably a safer option. The thick bones on top of the skull acted like built-in shock absorbers, and the horn-like postfrontals may have helped keep the opponent's heads from slipping during a shove match. But here's where it gets even more interesting. Recent research shows that Anteosaurus's head wasn't tilted quite right for the kind of head-on ramming matches we see in its plant-eating relatives, the tapinocephalids. Plus, it still had those massive canines. That's led some scientists to think that Anteosaurus might have done more showing off, flashing its teeth or giving warning bites instead of relying just on headbutting. And there's another idea too. Maybe those thick skull bones weren't only for fighting at all. They could have been there to help the skull handle the enormous stress of biting into big, struggling prey, something other top predators like mosasaurs and big carnivorous dinosaurs were also built to do. In 1954, paleontologist Dirk Boonstra described the teeth of Anteosaurus as those of a specialized carnivore. Its long incisors, massive canines, and relatively weak postcanines suggested that it didn't chew or slice its food, but instead tore off chunks of flesh from its prey. He also proposed that its recurved palatal teeth may have helped grip and tear meat. A year later, Boonstra argued that Anteosaurus had a sprawling crocodile-like gait based on its hip and femur anatomy, suggesting a semi-aquatic lifestyle. Decades later, in 2008, Mikhail Ivanenko went further, proposing that anteosaurs were semi-aquatic fish eaters, much like modern otters. However, this interpretation has been challenged. In 2011, Christian Kamara pointed out that the anatomy of Anteosaurus does not match that of typical fish specialists, which usually have long, narrow jaws and numerous sharp, recurved teeth. Instead, Anteosaurus had a deep, heavily built skull with blunt, robust teeth, a design better suited for subduing and processing large terrestrial prey. Its post-canines closely resemble those of tyrannosaurids, with thick bases and serrations ideal for bone crunching, suggesting that Anteosaurus may have been capable of breaking bones to access marrow. Stable isotope analysis published in 2020 also supports a mostly terrestrial lifestyle. The results showed that Anteosaurus had oxygen isotope values similar to those of other land-dwelling Permian animals, though slightly lower values leave open the possibility that it may have spent some time in water. Additional evidence from bone histology published in 2021 further supports a terrestrial lifestyle, as Anteosaurus bones had thick walls and completely infilled medullary cavities, traits common in land-dwelling animals. Interestingly, a few bones showed open medullary cavities with bony struts, suggesting that Anteosaurus may have occasionally waded or wallowed in shallow water, perhaps similar to modern hippos. Finally, groundbreaking research on the brain case of a juvenile specimen had completely overturned the old idea that Anteosaurus was a slow, crocodile-like predator. Using CT scans and 3D reconstructions, Julien Benoit and colleagues discovered that Anteosaurus had large inner ears and an enlarged region of the brain responsible for coordinating eye and head movements. These features indicate it was fast, agile, and an active pursuit predator, one that could track prey with precision and likely outrun competitors and victims alike. During the time of Anteosaurus, nearly all the world's land masses were joined together into the supercontinent Pangaea. What is now South Africa sat much farther south, close to the Antarctic Circle, yet the climate was surprisingly temperate. The Karoo Basin was a land of broad river systems, vast floodplains, marshes, and seasonal lakes. Winters were cool but not bitterly cold, and summers were warm and wet, with long daylight hours that fueled the rapid growth of lush Glossopteris forests along riverbanks. Towering horsetails, ferns, and other plants formed a dense undergrowth, creating a rich, green landscape teeming with life. The Abraham Scroll Formation, where Anteosaurus fossils were found, preserves this ancient ecosystem in remarkable detail. Sediments showed that powerful rivers flowed northward from the Gondwanide Mountains, carving channels across a low-lying plain and leaving behind layers of sandstone and siltstone. Fossilized footprints, ripple marks, and mud cracks reveal that much of the land was seasonally exposed, not permanently underwater, a dynamic, shifting environment that supported a thriving food web. Freshwater habitats were home to fishes like Athostonia and Nemeichthys, as well as giant amphibian predators such as Rhinosuchus. But it was on land where the real drama played out. The Karoo was filled with a dazzling array of therapsids, the mammal-like reptiles, ranging from small insectivores to massive plant-eaters. Herds of tapinocephalids, titanosuchids, and parasaurs browsed the vegetation, while carnivores of all sizes prowled in search of prey. And at the very top of this food chain stood Anteosaurus. The reign of Anteosaurus was dramatic, but relatively short-lived. This apex predator thrived during the Middle Permian, roughly 265 to 260 million years ago, dominating the ecosystems of the Karoo Basin in what is now South Africa. Like many of its contemporaries, however, Anteosaurus disappeared before the end of the Permian, leaving behind no direct descendants. Its extinction provides a window into the turbulent environmental and ecological changes that reshaped life on Earth long before the end Permian mass extinction. The first clue to Anteosaurus's fate lies in its timing. It belonged to the Dinocephalians, a diverse group of large therapsids that flourished during the Guadalupian or Middle Permian. Dinocephalians as a whole underwent a sudden and widespread extinction near the end of this epoch, a biological crisis known as the Capitanian mass extinction event. This event, which occurred about 260 million years ago, wiped out many dominant vertebrate lineages across Pangaea and fundamentally reorganized terrestrial ecosystems. The causes of this extinction are still debated, but are increasingly linked to massive volcanic activity in what is now China, the Emei-shan Large Igneous Province. These eruptions would have released enormous amounts of greenhouse gases, triggering rapid global warming, changes in atmospheric CO2 levels, and oceanic anoxia. On land, these climate disruptions likely led to hotter, more arid conditions, collapsing the lush floodplain habitats that Dinocephalians relied upon. Glossopteris forests and wetlands shrank, reducing available food for the massive herbivores that were prey for Anteosaurus. As the herbivore populations crashed, the large carnivores at the top of the food chain were among the first to feel the impact. Biologically, Anteosaurus was highly specialized. Its deep, reinforced skull and powerful jaws were built to tackle very large prey. Such specialization made it less adaptable when its preferred prey became scarce. Smaller predators, which could hunt a wider variety of animals, may have had a survival advantage during this time of ecosystem collapse. The extinction of Anteosaurus and its relatives was geologically rapid, likely occurring over a few 100,000 years, a brief moment on the evolutionary timescale. By the early-late Permian, Lopingian, Dinocephalians were gone, replaced by other therapsid groups such as Gorgonopsians and Dicynodonts, which would dominate the late Permian ecosystems. In short, Anteosaurus was both a victim of bad timing and ecological inflexibility. It lived during a period of global upheaval, and when the environment changed too quickly, even this apex predator, one of the mightiest hunters of its age, could not adapt fast enough to survive.